Everyone, good evening. So here we shall solve some more KCET previous year questions of the chapter ray optics and optical instruments. So in the previous three parts we had solved till the question number 47. So in this part 4 we shall start from question 48. So in these steps, if you have any, then write that in the comment section. To clarify them in the subsequent video. Any other chapter of physics, if you have more difficulty, then also write the name of that chapter in the comments. It will give more clarity on it. Questions chapter. Also some important homework questions we uploaded in the Sapience Education. So please install our Sapience Education application. The link has been provided in the description. So here in this question number 48, told that an object is placed at a distance of 40 centimeters from the pole of a concave mirror. So here one concave mirror is there. Now an object is placed at a distance of 20 centimeters. So u is equal to minus 20 centimeters. It is having focal length. Pole, this is focus. The focal length is 10 centimeters. The distance of the image formed is, so the focal length f is minus 10. Therefore, we know that the mirror formula, mirror equation is 1 by v plus 1 by u equal to 1 here. So we have to find v, 1 by v plus 1 by minus 20, that is equal to minus 1 by 10. 1 by v will be equal to minus 1 by 10 plus 1 by 20. So this will be equal to 20 is the LCM plus 1. So v will be equal to minus 20. Therefore, the image is also formed at distance of 20 centimeters. So v is also minus 20. Option E is the correct answer. Question number 49, it is told a candle placed 20 centimeters from candle is placed 20 centimeters from a lens, forms an image on the screen placed at 75 centimeters. Is 75 centimeters on the other side of the lens. Here is the lens. Here one inverted image form. If it is a convex lens, since concave lens will not form real image, since real image can be formed on a screen only. So since real image has been formed, so it should be a convex lens. It should be a convex lens. Since concave lens cannot form real image of real object. Concave lens will always form virtual image of object. Here this is formed on the screen. It is at a distance of 75 centimeters on the other side of the lens. It is 25. So we have to find the focal length of this lens. Type of lens is obviously convex. Now therefore here u is equal to minus 25 centimeters, u is equal to plus 75 centimeters. So therefore the lens formula is 1 by v minus 1 by u equal to 1 by f. 1 by v, 1 by 75 minus of 1 by minus 25, 1 by f. One by f, that will be equal to 1 by 75 plus 1 by 25. 1 by f will be equal to, LCM is 75. This will be 1 plus 25, 3 by 7. So therefore f will be equal to 75 by 4. 75 by 4 centimeter means it is approximately 4 1 by 4, 4 8 are 32, 15.75 centimeters plus. So the focal length is plus 18.75 centimeter, the convex line. Option A is the correct answer. Question number 50. So a certain prism is there is found to produce minimum deviation of 38 degree. It produces a deviation of 44 degree. Angle of incidence is either 42 degree or 62 degree. It means that when the angle of incidence is 42 degree, then the angle of the emergence is 62 degree. Or you can say when angle of incidence is 62 degree, then the angle of emergence will be 42 degrees. Hence why, since delta is equal to I plus E minus, so now angle of minimum deviation is, so the angle of deviation that is equal to I plus E minus A, and the angle of minimum deviation that will be equal to I plus I, 2I minus A. So since at minimum deviation we have that I will be equal to E, since R1 will be equal to R2, where I is the angle of incidence, R1 and R2 are the angles of refraction inside the prism, and E is the angle of emergence. So therefore here we can say that 44 degree, that will be equal to, so delta is 44 and I is equal to 42 degree and E is equal to 62 degree minus A. So from here you can find out the value of the angle of prism, which is A. So A will be equal to 42 plus 62 minus 44, so that will be 1 4 minus 44, that is equal to 60 degree. So the angle of prism is 60 degree, and the minimum deviation is 30 degree at angle tool. So what is the angle of incidence when it is undergoing? So this angle of incidence I will have. So I will be equal to be equal to A plus delta minimum by 2. Therefore I will be equal to 60 plus angle of minimum deviation, that is 38 by 2. Therefore I will be equal to 30 degree plus 19 degrees, so that is equal to 49 degrees. Option A is the correct answer. Question number 51, it is told point object moving uniformly towards the pole of a concave mirror. Point object is moving towards the pole of a concave mirror. It is having focal length 25 along its axis as shown. At t equal to 0, it is at the center of curvature at 50 centimeter pole of the mirror. Here is the focus. At t is equal to 0, the velocity is 1. Speed of the object is 1 meter per second. At t equal to 0, the distance of the object from the mirror is 50 centimeter. The average velocity of the image found by the mirror between t equal to 0 and t is equal to 0.25 seconds. Average velocity of the image. The average velocity of the image will be equal to the displacement of the image divided by time interval. Total displacement of the image divided by time interval. So therefore, at t equal to 0, u is minus 50 centimeter. Therefore, v will be equal to, we have to find, so 1 by v minus plus 1 by v minus focal length will be minus 25, since it is a concave mirror, it is equal to minus 1 by 25. Therefore, 1 by v will be equal to minus 1 by 25 plus 1 by 50. This will be, this we can write as minus 2 by 50 also. So it will be minus 1 by 50. So v also will be equal to minus 50. And similarly, at t is equal to 0.25, so the object is moving with a uniform velocity 1 meter per second. So at t is equal to 0.25, the position of the object will be minus of 50 minus v into t. Suppose it will reach somewhere here. So v into 1 into 0.25. So it will be minus 50 minus 0.25, so that will be minus 49.75 centimeter. Therefore, we have to find the value of v here. 1 by v plus 1 by v. Then 1 by v. 1 by v plus 1 by v equal to 1 by f. Therefore, 1 by v minus 1 by 49.75, that is equal to minus 1 by 25. Therefore, 1 by v, that will be equal to it's 1 by 25 plus 1 by 49.75. This will be equal to 0.75 into, I can write 45 into 25, so this will be minus 49.75 plus 25. Therefore, v will be equal to minus of 49.75 into 25 divided by minus 24.75. So this will be equal to 24.75. This will be approximately minus is 50.25 approx. This is actually approximately minus 50.25 253 centimeter approx. So therefore, the change in position of the image, therefore the displacement of the image, that will be equal to 50.253 minus 50, that is 0.253 centimeter, and this divided by time interval, that will give you the average velocity of the image. For the average velocity of the image, that will be equal to 0.253 centimeter divided by the time interval, 0.25 seconds. Should be approximately equal to 25.3 divided by 25 per second. So approximately 1. Here actually the question slightly it is wrong. Should be 25 seconds. 25 seconds, that t equal to 25 seconds. That t equal to 25 seconds, this will be 25, so this will become 25. This will be minus 25 centimeter. Therefore 1 by v minus 1 by 25, that is equal to minus 1 by 25. So 1 by v, that is equal to 0. That means v is in infinity. It means the image here it is formed at infinity. Image is formed at infinity. Therefore the average velocity of the image, that will be equal to the displacement of the image, which is infinity minus 50 centimeter divided by 25 seconds. So which will be equal to infinity. Therefore the average velocity of the image is infinity, and C is the correct answer. And in question number 52, it is told the refractive index of the refractive angle of a prism is A. This one is the A. The refractive index of the material of the prism is what? A by 2. So mu, the refractive index is what of A by 2. Then the angle of minimum deviation is. Therefore, the angle of minimum deviation, that is given as is 2i minus a which is also equal to so therefore I will be equal to delta minimum plus a by 2, r1 will be equal to r2 is equal to a by 2 at delta at minimum deviation. So therefore we can say that mu is sine r1, that is equal to 1 into sine I. Therefore mu will be equal to sine I, that is sine a plus delta by 2 divided by sine of r1, sine a by 2. So therefore here it is given the refractive index is cot a by 2. that is equal to sine a plus delta minimum. Cot a by 2 is equal to sine a plus delta by 2. So this into sine a by 2, that will be. This implies cot a by 2 is cos a by sine a by 2. So this will be cos a by 2. This will be cos a by 2, that is equal to sine a plus delta minimum by 2. And cos a by 2 I can write as sine of a by 2 plus pi by 2, that is 90 degree. Sine 90 minus theta. Sine 90 degree minus a by 2, that is equal to sine a plus delta minimum by 2. So therefore the angles will be the same. Therefore I can say 90 degree minus a by 2, that will be equal to a plus delta minimum by 2. Therefore I can say that a is equal to 90 degree minus delta minimum by 2. A will be equal to 90 degree minus delta minimum by 2. So therefore delta minimum by 2, that is equal to 90 degree minus a. So therefore delta minimum, that is equal to 180 degree minus 2a. The angle of minimum deviation is 180 degree minus 2a. Option B is the correct answer. In question number 53, it is told an object approaches a convergent lens. Object approaches a convergent lens from the left of the lens. Object approaches convergent lens. Convergent lens means convex lens from the left of the lens with a uniform speed u of 5 meters per second and stops at the focus. It will stop at the focus. Then the image will move away from the lens or move towards the lens. So when it will move towards the focus, as we know that when the object is at 2f, then the image is also formed at 2f on the other side, and when it slowly moves, and when it is in between f and 2f, then the image is formed beyond 2f. When it reaches the focus, then the image will move towards infinity. So approaches a convergent lens from the left of the lens with a uniform speed of 5 meters per second and stops at the focus. The image, so here the image will move away from the lens with a non-uniform acceleration. Means suppose here at any time t, u will be how much? U will be equal to at a uniform speed. So So let us suppose it starts from 2, then u is minus of 2f minus 5t. Speed I can say it as v naught is the object. We know that velocity of the image means 1 by v minus 1 by u, that is equal to 1 by x. So if we differentiate both sides with respect to t, then we will have minus 1 by v square into dv by dt plus 1 by u square into du by dt, that will be equal to 0. Therefore dv by dt, that will be equal to dv by dt, that will be equal to v square by u square into du by. By v minus of 1 by u, that is plus by 2f minus 5t. So v is a function of t. V by u also will be a function of t only. It means that it will have some acceleration. It means that dv by dt, which is the velocity of the image, that will be a function of time. So it is a function of time of t. So it means that image will move with a non-uniform acceleration three part. So option A is the correct answer. Then in question number 54, it is told object the following figure shows a beam of light converging at point P, and the concave lens of focal length 16 centimeter is introduced in the path of the beam at a place shown by dotted line, such that OP becomes the axis of the lens. The beam converges at a distance x from the line. The value of x will be equal. So here the concave lens placed here, and here is the actual object. Actually the object is here. The object is here. The point O. This is at a distance of 12 centimeter. Then Q is plus 12 centimeter. It means that the object distance is 12 centimeter. The object distance, that is 12 centimeter. So the image distance we have to find. So here actually the point P is a virtual object. It is a virtual object. So now the image will be formed somewhat farther since at a distance x. Here the image will be formed. This is the object. Object is at point P. So therefore V will be equal to plus x. So here we can apply the lens formula, and here the focal length is 16 centimeter, and since it is a concave lens, so the focal length will be negative, that is minus 16 centimeter. Therefore 1 by v minus 1 by u, that is equal to 1 by f. It is the lens formula. You can apply that. So 1 by x minus 1 by 12, that is equal to 1 by f, that is 1 by 16. Therefore 1 by x will be equal to 1 by 12 plus 1 by 16. So this will be equal to, so the LCM is 48, 48. So x will be equal to 40 This is minus 16. So the minus 16, so it is 4 minus 3. So it will be equal to 48 centimeters. So option B is the correct answer. Then question number 55 is told, in refraction, light waves are bent passing from one medium to second medium. Because in the second medium the speed is different, that's why the refractive index will change. So the speed of light in that medium is given as c by mu, that means the refractive index. So the speed will change. So that is why there will be some refraction. There will be refraction. So option D is the correct answer. Question number 56 is told, if the refractive index from air to glass is 3 by 2 and that from air to water is 4 by 3, then the ratio of focal length of a glass lens in water and in air is that the refractive index of glass with respect to air, that is equal to 3 by 2, and the refractive index of water with respect to glass with respect to air, that is 4 by 3. The ratio of focal length of glass lens, ratio of focal length of a glass lens in water and in air. So let's say the focal length in water is f1, the focal length in air is f2. Then we have to find out f1 is to f2. The focal length in water, the focal length of the lens, that is 1 by f1, that will be equal to the refractive index of glass by refractive index of water, which is mu relative minus 1 into 1 by r1 plus 1 by r2. That will be equal to, so this part will be a constant only, 1 by r1 plus 1 by r2, and into I can write is 4 by 3 into 4 by 3 by 3 by 2 equal to 3 by 2 by 4 by 3 minus, therefore 1 by f1. So let's call this part as some x, that will be x into 3 by 2 into 3 by 4 minus 1, 9 by 8 minus 1, that is equal to 1 by 8. So that is x by 8, suppose centimeter inverse. And similarly, in air, the focal length of the lens is 1 by f2. The refractive index of glass by refractive index of air minus 1 into 1 by r1 plus 1 by r2, that is x. This will be 3 by 2 by 2. It will be equal to x by 2. Therefore, we have to find f1 is to f2. So the ratio of the focal length, the glass lens in water and in f1 by f1 by f2, that we have to find. So it is 1 by f2 not by 1 by f1. 1 by f2 is x by 2, but by this is x by 8. So if we simplify it, then x by 2 into 8 by x equal to 4. 4 is to 1. So option D is the correct answer. Then question number 57, it is told, two thin biconvex lenses have focal lengths two thin biconvex lenses has focal length f1 and f2. A third biconvex lens has a focal length of f3. Third biconvex thin biconcave lens, focal length f3. Here, if the two biconvex if the two biconvex lenses are kept in contact, the total power of the lenses is P. So here the total power of the lens, that is P1, that will be equal to 1 by f1 plus 1 by f2. And if the first convex lens is in contact with the third lens, the first convex lens is in contact with the third lens, first the total power is P2. The total power is P2. So that will be 1 by f1 minus 1 by f3. Since here the focal length will be negative, this one should have negative focal length. If the second lens is in contact with the third lens, then the total power is P3. So P3 I can write that will be equal to 1 by f2 minus 1 by f3. P1 is how much? That we have to find. So this will be equal to f1 f2, f1 plus f2. Here P2 will be equal to f1 f3, f3 minus f1. This will be f2 f3, f3 minus f2. Option D is the correct answer. Then in question number 58 it is told the size of the image of an object which is at infinity. The size of the image of an object size of the image of an object which is at infinity. Size of the image of an object which is at infinity is formed by a convex lens. This is a convex lens. It is having focal length 30 centimeter. So the object is at infinity. Object is at infinity. Then the size of the image 2 centimeter. The image is concave lens of focal length 20 centimeter is placed between convex lens at a distance of 26 centimeter from the lens. That means that here the concave lens focal length is 20. Then the new size of the image that means here So the image will be formed at 30 centimeter when there is no concave lens. But when the concave lens is placed, then for it is at 26 centimeter from this convex lens. It means that for this the virtual image, so this image is acting as the virtual object. So here u dash is plus 4 centimeter. Therefore v dash, that will find v dash 1 by v dash minus 1 by u dash, that is equal to 1 by f, that is focal length is 20 for this. The focal length I should write minus 20 since it is concave. 1 by v dash minus 1 by 4, that is equal to minus 1 by 20. So 1 by v dash is equal to 1 by 4 minus 1 by 20, so 5 by 20, so this is 4 by 20. So v dash will be equal to 5. Centimeter. There should be plus 5 centimeter. Then the new size of the image. Now the magnification that is produced by a lens m, that is equal to v by u, and that is equal to height of the image by height of the object. So here the first image that is produced by the convex lens, that is acting as the object for the concave lens. So therefore here's the magnification, that will be equal to v, that is plus 5 by 4, that is equal to height of the image which we have to find by height of object, that is 2 centimeter. So therefore height of the image, that will be equal to 2 centimeter into 5 by 4, so that is 2.5 centimeter. So option B is the correct answer. Then question number 9 is told, consider a glass slab. There is a glass slab which is silvered at one end, the other side is transparent. This part is silver. Given the refractive index of the slab to be 1.5, if a ray of light is incident at an angle of 45 degree on the transparent side, 45 degree on the transparent side, the deviation of the ray of light from its initial path when it comes out of the slab. So there will be refraction here, and then here there will be reflection, then again here refraction, and then again it will come outside. So here this is angle I, so this will be equal to, this will be angle R, this will be also angle R, then this will be also R, this will be also R, this will be again I, which is 45 degree. Since if we apply the Snell's law, we shall see that here the angle of incidence or the angle of emergence, that is also 45 degrees. Now the angle of deviation of this light that we have to find. So this deviation is 45 degree. That means that angle of deviation, this is 90 degrees, so this will be 90 degrees. So from the original path of the incident ray, it has deviated by an angle of 90 degrees. So option B is the correct answer. Question number 60. Focal length of a convex lens will be maximum for which color of light? We know that focal length, the lens maker's formula is 1 by f, that is u minus 1 to 1 by r1 minus 1 by r2. So we know that refractive index equal to a plus b by lambda square, which is called as the Cauchy's equation, Cauchy's formula, where the refractive index is a function of wavelength of light. So when the wavelength is maximum, when the wavelength increases, then the refractive index will decrease. When the refractive index will decrease, it means 1 by f will decrease, it means f will increase. That means that when the wavelength increases, then the focal length increases. So the wavelength is maximum. The wavelength is maximum for red light. So therefore, the focal length of the lens also will be also maximum for red light. So C is the correct. Then in question number 61, it is told a ray of light passes through an equilateral glass prism. So equilateral glass prism. Equilateral glass prism, it means that the angle of the prism A, that is equal to 60 degree. Angle of the prism is 60 degree. Equilateral glass prism in such a manner that the angle of incidence that is equal to the angle of each of these angles is equal to 3/4 of the angle of prism. So I is equal to E, that is equal to 3/4 of 60 degree. So that is looking for the 60, so that is 45 degrees. The angle of deviation is, so therefore the angle of deviation that is equal to I plus E minus A. I plus E, that is 45 degree, plus 45 degree minus 60 degree. So this is equal to 90 minus 60, that is 30 degree. The angle of deviation is 30 degree. So option C is the correct answer. Then in question number 62, it is told convex lens here having focal length is L, and it is placed somewhere in between the object and the screen. Placed somewhere in between the object and the screen. Screen is placed on. The distance in between the object and the screen is x. If the numerical value of the magnification produced by the lens is m, so since the image is formed on the screen, so it is a real and inverted image will be formed. Real and inverted image will be formed on the screen. So here we have to find the focal length of this lens. Focal length L we have to find. So here, if the object, if the distance of the object from the lens, that is suppose y, then the distance of the screen from the lens, that should be equal to x minus y. The magnification produced is m, so m will be equal to v by u. So here v is plus x minus y and u is minus y. V by, so its numerical value, so mod of v by u is m. So therefore x minus y by y. Y is obviously less than x. Y is obviously here less than x. So m is x minus y by, then the focal length of the lens has been. So therefore, if we apply the lens formula, then we will get 1 by v minus 1 by u, that is equal to 1 by f. So this will be 1 by v, that is 1 by x minus y, and plus 1 by y, equal to 1 by x. Therefore, 1 by f, that is equal to y into x minus y, and it will be y plus minus 1. So the focal length is coming x minus y into y by x. Therefore, from here you can write m. M is equal to, you can write for x minus y by y, that is equal to m. So x minus y is equal to m into y. Therefore, m plus 1 into y, that is equal to x. Therefore, y by x, that is equal to 1 by m plus 1. Y by x is 1 by m plus 1. Minus y, that is equal to my. Therefore, the focal length is coming x minus y into y by x. Is equal to my square by x. So from here you can say y square by x square. So this you can write m into y square by x square into x. So y square by x square is 1 by m plus 1 whole square. Therefore, the focal length I can write it as mx by m plus 1 whole square. X by m plus 1 whole square. So option B is the correct answer. And question number 63 is told the power of an equiconcave lens. The power of an equiconcave lens, that is minus 4.5 diameter, say meter inverse, and is made of a material of refractive index 1.6. Refractive index is 1.6. Equiconcave lens, it means their radius of curvatures are same for both the sides. So on this side also the radius of curvature is r, on this side also the radius of curvature is r. Therefore, by using the lens maker's formula, we can tell 1 by f, that is equal to mu minus 1 into 1 by, that is minus 1 by r, since 1 by r1 minus 1 by r2, that is equal to 1 by, this is equal to minus 4.5. So I can say 1.6 minus 1 to minus 2 by r equal to minus 4.5. So minus minus cancel out. So this is 1.6 minus 1, so 0.6 into 2 by r, that is equal to 4.5. Therefore, the radius of curvature r, that is equal to 0.6 into 2 divided by 4.5. So this would be equal to 3 to the 6. So then 3 1 by 3, 3 5 is 15. So r will be equal to 4 by 15. 4 by 15 meters. So we can convert it into centimeters. So this would be 400 by 15 centimeter. 5 3 the 15. 5 8 the 40. So 80 by 3. So it is approximately 3 to the 6. 20. So this is the 18. So it is 26.6 and it is having minus sign since so option B is the correct answer. So hope all of you have understood the solutions of all these 53 questions in these 4 parts, this chapter on ray optics. And any other doubts if you have, then please write it in the comments. We shall obviously clarify them. And please install our Sapience education application. We shall upload some important homework questions on every chapter based on the previous year KCET exam. It shall be helpful for your KCET exam. Thank you everyone.